So one more example. We will hope for the best here. I don't work these things out in advance. They're all made up on the fly, and every now and then something goes wrong, and that helps us learn too. So, back to our cross. Okay, we've got a bearing here of south 72 degrees, 10 minutes east, going this way. And we got a bearing going back in the other direction of north 30 degrees, 17 minutes west. Going that way. Once again, remember the concept of the back bearing, because it's going to come in handy over and over and over again, believe me. Now, there's a number of ways you can approach this one. You got them in opposite quadrants. You could go this way. You could go this way. Either way, you're going to wind up with the same answer. What we are trying to find out in this particular problem is, what is this angle right here? The angle between these two lines. Well, how are we going to do that? This one gets a little complex. First thing we got is, this is north 30 degrees 17 minutes west, which means this angle here is 30 degrees 17 minutes. That's 30 degrees 17 minutes. So far, so good. We got one slice of this problem solved. But how are we going to get the other slice? Well, the other slice, we got two different ways of doing it, right? One, we'll do it the first way. First thing we know is that this right here is 90 degrees. Well, we also know that this is 72 degrees 10 minutes right here because of the bearing of that line. Well, if from this line to south is 72 degrees 10 minutes, and from south to east is 90 degrees, then this angle right in here, this little small angle, is going to be 90 minus 72 degrees 10 minutes. (90 degrees minus 72 degrees 10 minutes), which gets you to, I believe, 17 degrees and 50 minutes, if I did the math right. You know what? It's a great opportunity. Let's do some subtraction here with our bearings, or excuse me, our degrees in minutes. 90 degrees minus 72 degrees 10 minutes. All right. Well, this is 90 degrees 00 minutes. Well, you obviously can't subtract 10 from 0. So here's what we're going to do. 90 degrees is the same thing as 89 degrees and 60 minutes. So 89 degrees and 60 minutes is mathematically identical to 90 degrees. 60 minus 10 is 50 minutes. 89 minus 72 is 17. So we get 17 degrees 50 minutes. 17 degrees 50 minutes right there. which means our big angle that we're solving for, I'm going to erase this right here, give us a little room to work. Takes a little bit of getting used to writing on a smaller whiteboard. This big angle right here is 3017 plus 90 plus 1750. So we've got 30 degrees 17 minutes, 90 degrees 00 minutes, and 17 degrees 50 minutes. Add them all up. You get 67 minutes. 30 and 90 is 120. Plus 17 is 137. 137 degrees, 67 minutes. But wait, can't have 67 minutes. Remember, 60 minutes is a degree, so you gotta simplify that. So 137 degrees, 60 minutes. Take away 60 of those minutes and add a degree. So that only gets 138 degrees, 7 minutes. And that right there is the angle between these two lines, given the bearings that we have. Now remember I said there were two different ways to solve this. Well, I'm going to go at it a slightly different way. And in order to show the difference, I'm just going to use a different color. I'm going to switch to blue and see if we get the same answer. I'm going to erase this. We'll do a little bit different math. Now I'm going to leave the 1750. I'll leave all of those angles right there. Well, for our second methodology, what we're going to do is we're going to ignore the 90-degree quadrant from north to west, or excuse me, north to east entirely. We're going to simplify it, and we're going to just pretend that this line's not even there. You can ignore the east line completely because we know this is still 72 degrees 10 minutes down here, and we know it's 180 from north to south. So 180 minus 72 degrees 10 minutes. Oh, you wind up in the same situation we had before. So this 180 becomes 179 degrees 60 minutes. 60 minus 10 is 50. 179 minus 72 is 107. 107 degrees 50 minutes from north to that line. 107.50. 90 plus 1750, 107.50. That plus that is the same as that. You see, we come up with the same answer. We just went about it a slightly different way. And you add the 3017 to that. And we get 137.67, just like we had before. And once again, you can't have 67 minutes. So we're going to make this 138 degrees and 7 minutes. And we got the same answer. Two different methodologies, same answer. And once again, comes back to fundamentals. If you draw a good picture, it'll help you understand what's going on. It'll help you understand how to get to the solution to the problem at hand. And most importantly, really most importantly, if you draw a good picture and you're doing a bunch of math by hand or even on a calculator and you make a blunder and you come up with some sort of answer which you look at your calculator and the calculator says it's the answer, and you look at this picture, if the answer is off by a substantial amount and you've drawn a good picture, you're going to notice we came up with 138 degrees in 7 minutes from there to there, for example. If we had screwed up and come up with 78 degrees in 7 minutes, it would not take long of looking at this drawing to say, hey, I don't have a protractor, but I don't need one to know that that angle from that black line to that black line is a whole heck of a lot more than 78 degrees and any kind of minutes. So that's one of the ways it helps you. Anyway, I hope that this fundamentals of how bearings work and how they relate to angles was helpful to you. And I look forward to doing the next video. And I wish you all a pleasant day.